Hello everyone. Today we will be talking about MapReduce design technique. We have gone through the introduction previously. We said that there are two functions that need to be performed. One is map and the other is reduce. So the map function should be designed such that different nodes in the cluster will be able to perform the same task on different blocks of data that are visible to that particular data node. And after performing that operation, it will be emitting the output in the form of a key value pair. And also the input to all these mappers should be in the form of key and value pair. Okay, so we discussed that in the case of text files, this key will be the line number in hexadecimal form and value will be the line or the text itself. So this map function will be accepting the input line by line from a text file and performing some operation and giving the output in the form of key and value pair. All these will be sent to a single node or to multiple nodes, and these will be acting as the reducers which will perform the reduce operation, and after taking the input they are combined and it will be giving you a combined result. So map is the function that is to be performed in parallel by all the data nodes, and then the combination of all these individual intermediate results is done by the reducers to give the final output. So these reducers are accepting key along with a list of values here, and will also be giving us the output in the form of key and value pair. Okay, so let us discuss a small example here. So we are assuming that there are 10 documents D1 to D10, and here we are giving the words which are present in this document. Okay, so it will be read line by line. Here in this case, as there are only 3 words, they will be present in the single line. So this map function will be running only on this line, and here I am writing D1, but it will actually be specifying the line number. So if these are the 10 documents which the map function will be getting, so these 10 documents will be divided into different nodes, and say for example we just make certain assumptions here because we don't know exactly what will be placed where. So we are just taking the assumption that, say for example, these 3 documents are available in the first data node, next till 7 are available in the next data node, and last are available in the last data node. So here we have 3 mappers. So we are solving this with an assumption that there are 3 mappers. So if we say 3 mappers, the data is in 3 data nodes and we are processing it there. And here we are assuming 2 reducers. So previously we talked about 1 reducer which will take the entire input, but now we have 2 reducers. So this data is going to the first mapper, since this is the uh, data that is visible to this mapper. Okay, so first mapper, we call it M1. What will this do? It is again a word count problem. So we have already discussed a word count numerical where we saw a single document which has different text. Now we are assuming 10 number of documents with different words. So now what we'll do here, we have word and 1. So this logic we already know, we always have to append 1 here. Next is word 2, append 1. word 4 append 1. So what are we doing? We are just counting the words here. So word 1 once, next word 2 is coming once, and so on. Okay, so this is done for all the words. Take the word as it is and append 1 here as the value. Next, this goes to the second mapper and we have M2 here. Again, take all these words as the key and the value is 1. So this is the logic which we have already seen. And this is done for all the words of all the documents which are visible to this M2. Next, for M3 or the third mapper, whatever are the words here, W2 one time, again W2 one time. If you see, we are not adding it here, we just have to take the word as it is and append a 1 here, and this is done for all the words which are visible to this M3. And then we will be applying the sort and merge phase. So this we have discussed. So this will be applied here on this mapper itself. So we are just sorting them and merging the data into a single list before we can send it to the reducer. So here W1 is the key, and how many times is it appearing, that will go in a list. So it is 1 from here, next it is 1 from here. Okay, so it is appended in a list. Next, word 2, so how many times will it come? So this is W2 here, so we have 3 times, so we'll write 1 2 3. Next is word 3, so word 3, it will have 2 ones in the list. Word 4 will have 2 ones in the list again. So similarly, this sort and merge will be applied by these mappers also, and we will have the merged list of values. Here there are 4 ones. Okay, then for W2 and so on. Similarly, here we have W2 1. So this will be sorted, so it will be W1, W2, W3 and W4 again, along with all the list of values which are visible here. Okay, and then all these are copied into reducers. Now since in the previous example which we discussed, we saw there is only one reducer, so everything was going to the same reducer, right? But now we are saying there are two reducers, so there will be some data that will be going to this reducer number 1, and there will be some data that will be going to this reducer number 2. Okay, so let us assume here that word 1 and word 2 will be coming to this reducer, and word 3 and 4 will be coming to this reducer. So we are just making an assumption here. It is decided by Hadoop, so wherever it goes, we do not know about it, but here we are just making an assumption. So now this data W1 needs to go to this reducer. So this data is simply getting copied from here to the reducer. So this is called as message passing, where we are not doing any operation on the data. It is just copying the data from the mapper to the reducer. So it is going from one node to the other node. Similarly, W2 again we said that it will be coming to this reducer. W3 is going to this reducer, so this data gets copied here. W4 is also going to this reducer, so this data is getting copied here. So we are just passing the intermediate results from these nodes to the other nodes. W1 goes here, W2 goes here, and so on. So here we will have the data about 1 and 2 with this reducer and about 3 and 4 with this reducer. Okay, I'm just not writing the data here. It is expected that you all will complete it. And then this reducer will be performing the summation operation and giving the output. So what will be the output here? And what will be the output here? It will be the data which is visible to only these two reducers. Okay, so here only W1 and W2 are visible. So the output will be W2 along with its count that is visible to only this reducer 1. Okay, so W1, how many times it appears? It appears 9 times. And W2, it appears for 10 times. So this will be the output by this reducer. And here the output will be the count of W3, that is 8, and count of W4, which is I guess 7. And then both these results are merged and given as the output to the user. Okay, so this is about how the map reduce for word count works if there are multiple documents which will be stored at different data nodes. Okay, so this we have seen superficially that D1 or this entire document is available in this data node, but it may not be the case that this entire document is present in this data node. But here we are assuming a smaller document which will be accommodating in the same data node, so this entire content is here. However, if the file size is greater than 128 MB, it will this D1 or the first document will also be divided into different data nodes here. So we have D1, this content whatever is visible. We may also have D1 again with whatever content is available at this place. So that is possible. It will still give us the same answer since we are not considering the document. We just need to count the total number of occurrences of these words across all the documents. So we do not want the result document wise, we want it for all the set of documents. So this design technique will work here. Okay, I hope this is understood to all of you, and if there is any doubt we can take it up in the discussion in the next lecture. Okay, so this was about counting. We will look at a few more examples in the coming lectures. Indexing, how we can index the documents, locality sensitive hashing, likelihoods, finding probabilities, TF-IDF, and there are many such problems which we can discuss. So I'll take up indexing also in this video. So what is indexing? In indexing, we are trying to find out, say we have a word, we need to find out all the documents in which that word is present. So that is called as indexing, right? So we have discussed this in the second unit. We'll see how to solve that problem using this map reduce technique now. Okay, so if you see here, here there is a small technique about what mapper should do and what should be done in the reduce function. So in the map function, we need to produce a partial index. So what are we expecting to do? Whatever is visible to this mapper, it will consider as input. And what is it expected to do? It is expected to emit W along with this posting list is nothing but the index or the document in which that particular word is present. Okay, and then here you will be message passing and giving the data to the reducers, and reducer will be combining the results based on the key. Okay, so this we have discussed here. Here it is combining the results based on the key, which was this word. Similarly, here also the key will be word. Okay, so reduce key is word based on which it will be combining the results. So we can explicitly specify that the reduce key is word. Okay, so let us discuss a small example using indexing. Using this technique of MapReduce. Again, we'll assume that there are three mappers, and if this is not given in the question that how many number of mappers are there, then you may decide on how many number of mappers you wish to use and how many reducers you wish to use. If it is given, then you have to use the data which is given to you. So what is the input here? We will assume that there are few documents and there are words which exist in this document. So document 1 has W1, W1, W2, W4. So it has these four words. Document 2 has these four words present, and we assume that these two documents are available and visible to mapper number 1. Okay, next there are two more documents which are visible to the next mapper. So this distinction may not be given to you that which document is present where. It is just an assumption. Which document is present where, you can specify it. These are the next two documents which are visible to the mapper number 2, and then there are two more documents which will be visible to mapper number 3. And document 6 has these words. Okay, so now whenever you are designing a solution using this MapReduce technique, you are expected to specify what will be the input to this map function and what will be the output. So we know that it should be key value pair, right? So this key value is getting converted into some other key value pair. Okay, and then what is the key and what is the value which we are getting? So we say that k1 or this key is nothing but the document id or the name of the document, and value is the words which are present in the document. Okay, so this is the input that we are expecting in this case. And what is the output here? So output is what will be the mapper giving? It will be giving is what is the word, and then along with it the value will be the document id in which that word is present. Okay, so this is what the mapper is going to give as output. So let us see here what will this mapper perform as a function. It will write W1 which is present in document 1. Next again W1 present in document 1. W2 present in document 1. W4 present in document 1. So here we are done with document 1. We take the word and value is the document ID. Okay, so let's do it for the remaining words. So W1 again, but now it will append D2 here. Next is word 2 appending D2 as the document ID. Word 3 with D2. Next word 4 with D2. So this is the output coming from this map function. Similarly, you will have outputs coming from map 2 and map 3. right? So what will be this giving? You have to write the word along with the document ID, next word along with the document ID, and this continues. Similarly, third mapper will do it for whatever is visible to this mapper. So word 1 in document 5, word 3 in document 5. So do it for all the words, and that will be the output that you will be getting from map. And after this you will be applying sort and merge operation. So after sort and merge, so basically this will be happening inside the mapper itself. Okay, so you may also combine these two and directly show this as the output, or if you want you can show the sort and merge phase separately. So here what we'll do, we'll have word 1 and we are merging all the document IDs which are there here. But now if you see, you need not count if D1 is appearing twice. We are not expecting to have the term frequency here. We are just creating the index. So we will have D1. So if that document ID is already listed, then we will skip that and move to the next item. So after combining, we have word 1 present in D1, D2, word 2 present in D1, D2, word 3 present only in D2, and word 4 is present in both D1 and D2, and it is all getting merged here. Similarly, whatever is visible here also you will merge it in a list, and here also you will be merging it in a list. So again here it will be sorted. We have W1, 2, 3, 4 and same here. So this is the output of sort and merge phase, after which you will be message passing and giving these to the reducers. So you again have to decide what will be the input to the reducer 1 and what words will be going to the second reducer, that is reducer number 2. So for example, again here we assume that word 1, word 2. So what is it passing based on? It is passing based on the reduce key, which is word again. So all the word 1 along with it lists will be coming here. So word 1 coming from here and word 2 also coming from here. So all word 1 and 2 will be coming from all the mappers to this reducer. Word 3 and 4 will be going to this reducer number 2. Okay, and then what will this reducer do? It will operate upon whatever data is available in this reducer and give the output that is based on the data it has. So here the output will be word 1 and the documents which are having this word 1. So if you see here, in this case the output is a list. So it is possible to have a list as output. So W1 is present in document 1, 2, it is 4, 5 and 6. Okay, so this is the output of W1. Similarly, you will also have output for W2. It will be present in D1, D2, D3, D4 and D6. Similarly, you will be getting the output about W3 and W4 from here. Okay, I hope it is clear to you, and all of you are expected to complete whatever is not written here. And this is about how we can perform indexing using MapReduce. Thank you so much. Have a nice day.